So starting with problem number 8, first thing you need to do is factor. The top is just greatest common factor. And the bottom is already factored. You can separate these, so you can make that a 1, make that a 5, make that a 1, make that an x, and the answer is x over 2x plus 1. And domain restriction, x cannot be equal to 0 because that's what makes the denominator 0. Next one, when you factor the top, you factor out an x, and you're left with an x squared minus 4. This is now a difference of squares. It is x plus 2, x minus 2. And here on the bottom, using the x method, I'm just going to quickly factor it. It is x plus 6 and x minus 2. You can see the domain restrictions. X cannot be equal to negative 6 or positive 2 from these down here. And these cancel, and there's my final answer. X over x plus 2 over x plus 6. All right, the next one is multiplication, which same idea. It just, you have more terms on the top and then the bottom. This is x plus 4, x minus 4. And we still have the x to the third because we're really just pushing all these together. This here, factor out an x, left with an x minus 4. And this here is in the wrong order. It's a negative x plus 4. And you don't want to start with the negative, so I factor out the negative 1, which is going to change all the signs. So now I have a negative 1 down here and an x minus 4. That negative 1 I will pull out to the front in a minute. I can take one of these x's and two of these away. And here's what I'm left with. An x plus 4 over an x minus 4. And I still have an x squared up here. And that's a quantity. And the whole thing is a negative that I can just pull out in the front. Domain restrictions. X cannot be equal to 0 from this. 4 and that's it. That, because that's the same as that. Those are my two domain restrictions. All right, the next one here, again, factor out a negative 2. That's going to leave me, I'm going to do it down here. That's an x plus 2, that sign changes. Difference of squares, x plus 3x minus 3. This is a keep, change, flip, so I'm keeping the first one. I'm changing this to multiplication, and I'm flipping this. When I factor this using the x, it is x minus 3 and x plus 1. And when I factor this, it's 2x plus 1 and 2x minus 1. It's a difference of squares. You can see I have 4 domain restrictions. X cannot be equal to negative 3, positive 3, 1/2, and negative 1/2. Those fractions are coming from that, subtracting, adding, dividing. And these go away. Wow, that's messy. And what I'm left with is a negative 2, x plus 2, x plus 1, x plus 3. I just realized I messed this up when I factored out a negative 2 here. That leaves me with the 2x plus 1. My bad. So there we go. That cleans it up a little bit more. Those are gone. So what I have on the top is that, and what I have on the bottom is an x plus 3 and a 2x minus 1. There's my answer. All right, this is another keep, change, flip, which of course we have to factor first. So this is just greatest common factor. Bottom is also greatest common factor. Keep, I'm changing this, I'm flipping this. The x plus 4 is going to go at the top. It is a quantity. This is a difference of squares, x plus 1, x minus 1. Starting to cancel, boom, 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 gone. You have to put a placeholder of 1 on top, x plus 1's on the bottom. Domain restrictions, x cannot be equal to 0, negative 4, negative 1, positive 4. All right, when you add and subtract, you have to have a common denominator. So you can see I already have a common denominator right there. So all I have to do is subtract, and keep in mind, when you subtract, you have to distribute that negative. So you have a 4x minus 2 minus an x plus a 2. That's on the top, and on the bottom we have simply the x plus 4. That doesn't change. 2's cancel. 4x minus x is 3x. You have an answer of this. Domain restrictions, x cannot be equal to negative 4. Next one, again, common denominator, which you don't have this time. So we have to multiply this side by x plus 2, top and bottom. And we have to multiply this one by x minus 2, top and bottom, because there's no way you can get those to both be the same. All these are quantities, so we're going to FOIL. So we're going to FOIL this. I'm going to do it rather quickly. You get 4x squared. You have a negative 7x minus a 2. And then in FOILing this, we have an x squared plus a 3x plus a, oops, I should have just wrote 5x. I'm going to change that. Kind of skipping a few steps here. I'm combining my like terms, plus a 6. So all of this is over x minus 2x plus 2. And when I combine what's on the top, I have 5x squared. I have a negative 2x and a positive 4. Remember, you don't have to worry about factoring that. Almost always it's not going to be factorable. So x cannot be equal to or negative 2. Again, on this one, common denominator, but this is a negative, which means it's really a negative 1 right here. So when you distribute the x to the x minus 4, you're going to distribute a negative 1. And then this is x plus 1. So in distributing the 6x to the x plus 1, it's 6x squared plus 6x. Now remember, I'm distributing a negative, so I have a negative x and a positive 4. And that's all over the x minus 4 and x plus 1. And combining my like terms on the top, I have 6x squared plus 5x plus 4 all over the quantity x minus 4, x plus 1. X cannot be equal to 4 and negative 1. All right, complex fractions, combination of both of these. You're going to combine what you have on the top first. This is already combined, but I can factor this. And then on the bottom here, I have to find a common denominator of x, which is going to leave me with an x plus 1 over 2x. And now what I have is keep, change, flip. So I keep the first one. Change to division to multiplication, flip this. And as I cancel, those go away. I can separate the 2 from the x. So what I have is 2 times the quantity x minus 1. There's just a 1 on the bottom. I don't have to write that. X cannot be equal to 0, negative 1. All right, next one right here, finding a common denominator. Oops, let's see. Finding a common denominator on the top is multiplying this by an x minus 1. So I have an x squared minus an x minus a 6. I'll have to factor that. That's my numerator. On the bottom here, I'll multiply both by x. So I'm going to get an x minus 3, which is a quantity, over an x. When I factor the top using the x method, it will factor into this. And that's what I'm going to keep. I'm going to change the division and flip this. So now I have x minus 3 over x plus 2 over x minus 1 times x over x minus 3. And those cancel, and that's all that cancels. So my answer is going to be x times the quantity x plus 2 all over x minus 1. Domain restrictions, x cannot be equal to 3 and 1. All right, next one, again, quantity, common denominator, forces you to multiply by an x minus 3. But keep in mind it's subtraction, so really it's plus a negative. You're distributing a negative. And on this side, x minus 2 and an x minus 2. So in the numerator, you have x minus 2 minus an x, 2x, plus a 6. Here's an x minus 2, x minus 3. On the bottom, quantity, also distributing a negative. On the right-hand side, it's a plus a negative 3. And this is x minus 3, x minus 3. So in the denominator, you have that x minus 3, x plus 1, minus 1. And in the numerator, you have 2x minus 6, negative 3x plus 3. And once we clean this up, we'll keep, change, flip. We have a negative x plus 4 on the top. I'll factor out a negative 1 to make that an x minus 4. And then on the bottom, I have the x minus 2 and x minus 3. That's what I'm keeping. changing the division. Here I have a negative x minus 3, but I'm going to factor out a negative 1. Oh, this is going to flip, so that's actually going to go on the bottom. And make that an x plus 3. And then this x minus 3 and x minus 1 is going to go to the top. These go away. These go away. I'm left with x minus 4 and an x minus 1, x minus 2 and x plus 3. X cannot be equal to 2, 3, and negative 3. That 1 has no effect because it's not an x. All right, for the next problem here, very similar, x and x. You have an x plus 5 on the top, 3x on the bottom. This is already factored. Not factored, but the only thing I have to do is factor it. Now I'm going to keep change flip, so I have the x plus 5 over 3x. I'm keeping that. Changing this to the x over x plus 5, x minus 5. These go away. X's can be separated. You have to have the placeholder of a 1, and this is what your answer is. Domain restrictions 0 because of this, negative 5 and positive 5. All right, in the next part, you find a common denominator between all 3 of the terms. So this one I'll multiply by 6, this one I'll do by 2. And this is a quantity, and when I'm multiplying by 2, because it's subtraction, it's really a negative 2 plus a negative. So I'll distribute that. So what I have on the top is a 6x, and I have a minus 2x minus a 6, and that's going to be equal to a 2x minus 4. And every one of these terms here are over 12, and if I multiply that away, I can look at just what's in the numerator and use just that equation to solve. So 6x minus 2x is 4x minus 6 equals 2x minus 4. When I subtract the 2x from both sides, I get 2x, and I'm going to add 6, is equal to 2, so x is equal to 1. And that's not an extraneous solution. I don't have any because there's no variable in the denominator. But my next one, I do have possible extraneous solutions because x cannot be equal to 3 or 0. You can see that from the beginning. So if I get one of those answers, I have to cross it off. That would be an extraneous solution. So again, finding a common denominator, I'll multiply that by x. I'll multiply this by x, have to distribute there, and multiply this middle one by an x minus 3. And then, because I now have a common denominator, I'm not going to rewrite this one all out, I can multiply it away. So in other words, I can just ignore it and work with my equation on the top. When I distribute that 1, it doesn't change anything. And you can see I have an x squared, meaning I have 2 solutions, so I'll have to use the x method to solve and factor. So I have to get one of the sides equal to 0. So I have x squared minus a 3x. Oops. It's actually going to be a negative 4x because I'm going to subtract another one, and then the 3. And this equals 0. So again, that's a 4. Using the x method, I'm just going to write the answer here really quick. I get x minus 3 and x minus 1. And this solution is x equals 3. And this one is x equals 1. But you can see I cannot be equal to 3, so that one's gone. So my solution is only x equals 1. All right, the next one, same thing, quantity, quantity, find a common denominator so I can multiply it away. So I'll multiply all that side by x minus 8, this one here by an x minus 5. I'll have to distribute on both of them. You can now see the denominators are the same, so if I multiply them away, multiply everything by that, it'll be gone, and I'll have a 4x minus 20 equals a 3x minus 24. And in subtracting, I'm going to get x equals, add 20, it's going to be negative 4. And my domain restrictions from the beginning were x cannot be equal to 8 or 5, which this isn't either of them, so that answer is going to work. Next one, common denominator again. This is going to be an x plus 2 to the top and bottom. This one's going to be an x to the top and bottom. And then with my denominator being the same, I'll multiply it away to make it go away so I can ignore it. Distribute the 2. I have only one solution, so I simply solve, and I get 4 equals x. My extraneous solutions were 0 and negative 2, which isn't on the list, so that is my answer. Next one, it's all factored except for this part, so I have to factor this into x plus 3 and x minus 2. And now you can see that my common denominator is only going to be multiplying this one by an x minus 2. So now, of course, I can multiply that away. So that's gone. That's gone. Now I have a 2x minus 6 equal to a 2x minus 4. And watch what happens when you subtract the 2x from both sides. They're gone, and I'm left with a statement that is not true. Therefore, there is no solution. Next one, very similar. XX. Oh, this is a repeat. I already did this one, so I'll skip it. All right, Chapter 7, Radicals and Complex Numbers. This is where we have to break these down. And this is a square root, so we're looking for pairs. So let's break down the 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. So I have one pair, two pairs, that takes out 2. So I already have a negative 2, and then I'm going to take out a 2 and a 2. This 3 is going to stay inside here. And then with the A's, I have 3 A's. One takes 1 to the outside, that one stays. B's, I have 4 B's, so I have 2 groups of 2's, so B squared. And C, I have C and C, so that's 1. There aren't any B's or C's left inside. So negative 2 times 2 times 2, I have a negative 8 AB squared C times the square root of 3A. And next problem, very similar. Break down the 36, 2 and 8. Well, 36 is a perfect square, so I could continue to break this down, but eventually what I'm going to get to is 6 and 6. So you can see pair of 2's, pair of 3's. So I already have the 4 here, and then I have a 6. X squared takes 1 out, leaves 0 inside. Y squared takes 1 out, leaves 1 inside. Z to the 4th takes 2 out, doesn't leave any inside. And if I multiply these together, I'll get 24xyz squared times the square root of y. As my final answer. Looking at the next one, I have to break these down too, but if I have a negative under there, that takes out an imaginary number. So I have to do that with that one, and that one. So apparently all of them. So this, when I break down the 12 now, I have 3 and 4. I have 2 and 2. That's 2 root 3. So what I already have a negative 3i here. So that becomes a negative 6i times the square root of 3. This doesn't change because I can't break that down. And when I break down the 20, I have 2 and 10, 2 and 5. So 2 root 5, but I already have a 3i, so 3i times 2 is 6i times the square root of 5. Now these are like terms and these are like terms, so those I can combine the coefficients in the front to have negative 3i root 3, and this is just going to tag along like this. And that right there is my final answer. Likewise, the next one, take out the imaginary unit. I have negative 2i times the square root of 45 minus 3i times the square root of 20. We already broke down 20. We know it's 2 root I, or 2 square root of 5. So I already have the 3i, and of course subtraction. So 2 times 3i is 6i times the square root of 5. Breaking down the 45, I'm going to end up with, it's going to be 9 times 5. So it's going to be 3 root 5, but I already have a negative 2i, so 3 times negative 2i is a negative 6i times the square root of 5. And what do you know? I have like terms here, so I'm just adding the coefficients. A negative 6i and a negative 6i is negative 12i. The square root of 5 is just going to tag along. Next one's very similar. Take out the imaginary unit so I can work with this. We already know that 8 is 2 square root of 2, and 18 is, so I have a 2i. 18 is going to be 3 square root of 2. So I have 3 square root of 2. And this time it's multiplication. So whatever's outside, this is a 6i square root of 2. And times a 2i square root of 2. This is multiplication. You can multiply anything together. Whatever's outside will be multiplied together and stay outside. So that's 12i squared. And whatever's inside the radical can be multiplied together and stay inside like this. I now have a perfect square there. I know that's equal to 2. So now I have 12i squared times 2. Well, I have a few things I have to do. I have to change I squared to -1, and I also have to multiply these together. So what I'm going to get is -1 times -24, -1 times 24, so I get -24 for an answer. Next one, very similar. Take out the imaginary unit first before you can even move on. So now I have 2 times I times the square root of 12 plus I times the square root of 9. And I can work with these. I know this is 2 root 3, so it's 2i root 3, still in parentheses, because I have to distribute this 2. This is a perfect square, so that's simply equal to 3i, because 3 times 3. When I distribute this, it only goes to what's on the outside, so it'll be multiplied to this and this, because both those are outside. I won't change that. That'll just carry on. So I have 4i squared of 3 plus 6i, and that is my answer right there. Okay, next problem. Remember, you can't have a radical in the denominator, so if you do, you have to remove it. If it is just a radical with a term under it, you simply multiply it by itself. And now I have square root of 2 times square root of 2, which is equal to the square root of 4, which is a perfect square. It's equal to 2. Radical's gone. It moved up to the top. I have square root of 6 times square root of 2. They're both under the radical. I can multiply them together. And I already know when I simplify that, that is 2 square root of 3. And because these 2's are on the outside and not part of quantities, they can simplify away and leave me with square root of 3. Next problem is exactly the same, other than that's a quantity. Ignore the 4 for right now. That can stay there. The only thing we're trying to do is remove that square root of 3 from the denominator. So that is going to remove that, because that's the square root of 9, and the square root of 9 is 3. So down on the bottom, I have 4 times 3, or 12. On the top, I will distribute this. So when I do that, I'm going to get 2 square root of 3 minus square root of 24. I will break down that 24. It's 2 and 12. It's 2 and 6. It's 2 and 3. I have a pair of 2's. This is extra, so that'll stay inside. So what that's equal to, I'm going to write it down here, is 2 square root of 6. And all of that is over 12. I do have a greatest common factor here on the top that I need to factor out. Both the outsides are divisible by 2. When I factor that out, it doesn't change anything with the radical, but that will allow me to reduce my fraction right here. So my final answer, which I really don't have room to write, is square root of 3 minus square root of 6 all over 6. All right, the next one is different because that's a quantity, that's a quantity. If you have a quantity and you're trying to move a radical, you can't multiply by itself. You have to multiply by the conjugate. Same first term, sign changes, same second term. So 4 minus square root of 3 to both the top and the bottom. I have to FOIL the numerator. I'm going to have a lot of stuff going on here. So I have 8 minus 2 square root of 3. And then I have 4 square root of 3 minus square root of 3 times square root of 3 is square root of 9, which is equal to 3. So that'll be on the top. In FOILing the bottom, I have 4 times 4 is 16. I have negative 4 square root of 3. And then here's a positive 4 square root of 3. Remember, those have to cancel, and they do. And then here I have minus square root of 9. Square root of 9 is equal to 3. So if I now, I'm going back up to the top. I should have just finished the top, but because I don't have much space, I didn't. I can combine those two middle terms. Oops, that's a minus 3. So let's just go ahead and make that an 8 minus 3. So 8 minus 3 is 5. And then on the bottom, we said these cancel, and this is equal to 3. So we have a 16 minus 3. We have a 13. There is no greatest common factor on the top. Can't go any further. Okay, next one, pretty easy because an I is the square root of -1. We can't have a radical in the denominator, so we have to also remove the I. So I'll multiply top and bottom by I because it's not a quantity. That puts 7i on the top and 2i squared on the bottom. We know I squared is equal to -1, so that's going to make this our answer right there. Next one is truly exactly the same. You just ignore the 4, multiply by I, but this is a quantity. I'll have to be distributed. So I have a 2i minus I squared. I'll have to remove that in a second, over 4i squared. So this becomes a -1, so I have a minus -1. So it's going to be a plus. So I have a 2i plus 1. And this is a -1, which makes that a -4. So I'm going to flip the order of this because remember I want my number first. And this right here is the answer. And the last one is a quantity here, quantity here. Okay, so now just like the problem above, I have to multiply by the conjugate. Same first term, so it stays negative. Change the sign, same second term. So -4i minus 1. And foiling on the top is going to give me a -8. I have a -2i, a -4i, and then I have a -i squared. So in combining my two middle terms, I have a -6i, so I have -8 minus 6i, and I squared is -1, but it's a -1, so it becomes a +1. So on the top now, I have -7 minus 6i. On the bottom, negative times negative is positive, so I have 16. Negative times negative is positive, so positive 4i. Here's a -4i, and here's a -i squared. Again, my two middle terms cancel out, so I have 16 minus a -1 or plus. So on the bottom, I have a 17, and no greatest common factor. You don't have to worry about factoring out that negative there because there's no negative on the bottom, nothing to simplify, so you're good with that. All right, this next part is pretty easy. You have to write it as a rational exponent. Rational memories fraction. So this is your number. This right here remains the power, and this is the root, which becomes the bottom number. The roots go in the ground. This is 6 2/3. The next one, you need parentheses. You don't see the number right here, but it's a 1. You don't see the number right here, but we assume it's a 2. So it's that right there. And the last one, because it has a number in the denominator, it's going to be a negative exponent. So you're going to have 3x. The number right here is 2, so it's going to be 5/2, but it will be negative because it's on the bottom. And again, that one needs parentheses. Doing the opposites to write it in radical form, you write it as a radical. 2x goes underneath. I always use parentheses if there's more than one thing. The negative means it's a fraction. And then this is a 1/4. So it's the power is 1, the 4th root, the 4 is the root. X to the 1/2 is the same as the square root of x because the 2 would go here and the 1 would go there, but of course we don't have to write it. The last one is going to be 10x. Here's our square root. It is a square because the root is a 2 and the power is a 3. Again, parentheses are necessary. Don't have to put the 2 on the outside. The next one says you have to write it as an integer reduced fraction. In order to do that, you first need to write it in radical form. So you're going to write this as 36. It is squared and it's to the 3rd power. So this is 36 times 36 times 36. And we're looking for pairs, so we immediately have a pair that we could take out. So we'll take out the 36. And now we need to break this down to find a pair, and what we get is a pair of 6s. You could break it down into primes, but if you find a number, that's better. So now we have also a 6, so we have 36 times 6, which is 216. The next one has a negative exponent, so it's going to be a fraction, but let's just work with this. It's the 3rd root of 8 to the 1st power, but it's a fraction. 8, if we break this down, it's 4 and 2, and 2 and 2. We're looking for groups of 3, and we have one group of 3 of the 2's, so that is equal to 1 over 2, or 1/2. Next one is the 4th root of 81 to the 3rd power. So this is 81 times 81 times 81. We're looking for groups of 4. We don't have 4, so we'll break these down. Breaking them down in 9s is good, because anytime we find a pair, it could be a pair, or 4 rather in this one, 4 of anything. So that'll take out 1 9, and if we make these 3's, that'll also take out 1 3, so 9 times 3 is 27. The answer for that is 27. Okay, looking at solving for x when we have radicals, and it says check for extraneous solutions here. So when you have a radical, you want to isolate the radical. This one's already isolated, so is this one. As soon as they're isolated, you can then square both sides to remove them. That'll leave you with the 2x plus 4 equals a 5x minus 8. If I solve for x, I'm going to subtract 2x from both sides. That gives me a 3x over here. I'm going to add 8 here. That gives me a 12 here. And dividing by 3, I get x equals 4. And I'm looking for extraneous solutions. If I go back and plug in the 4 for the x, I get 20 minus 8 on that side, so the square root is 16. When I go on this side, I have 8 plus 4. Square root of 12, not 16. And then 8 plus 4 is also square root of 12. That checks out. It works. All right, remember, typically it's the negatives that you're looking for. Next one, before you can square both sides, this has to be isolated. So you need to take and subtract 3 from both sides. And as soon as you do that, the radical is isolated, and you've created a quantity on this side. So when you square both sides, you are going to have to, these two will undo each other and leave you with that x plus 9. But on the other side, you're going to have to expand out x minus 3 times the quantity x minus 3. I'm just going to say what that is really quick. X squared minus 6x plus 9. You have an x squared. You've introduced an x squared. You're going to have 2 solutions. One of them you will most likely have to throw out. I'm going to set one side equal to 0. Oh, I have 7x squared minus 7x. So all I have is a greatest common factor of x. And now I can find my 2 zeros. This one here is x equals 0. This one here is x equals 7. But I need to check my answers. So I'm going to start with 0. And when I plug in 0 in for the x, I get 0 plus 9. So I get 9. Square root of 9 is 3. 3 plus 3 is not equal to 0. So that one is an extraneous solution. It doesn't check out. And the next one, when I plug in a 7, I have 3 plus the square root of 16. And I want to see if that equals 7. And it does, because 3 plus 4 is equal to 7. So x equals 7 is the answer that checks out. All right, next one right here. So it's very similar to the last one we did, but a little easier because this is already isolated. So I'm going to square it. I'm going to square this. I just introduced an x squared, so therefore I'm going to have 2 solutions, one of which I will most likely have to throw out. I'm going to set one of the sides equal to 0. And in doing that, I'll be able to factor this. With the x method, I'm going to factor it quickly. It factors into x minus 4 and x plus 3. And the 2 zeros are solutions. This one is x equals 4. This one here is x equals negative 3. And if I go back now and plug in my answer of 4, 4 plus 12 is 16. Square root of 16 is equal to 4. That checks out. When I plug in negative 3, I have negative 3 plus 12. That is equal to, negative 3 plus 12 is 9. The square root of 9 is 3, but 3 is not equal to negative 3, so that is an extraneous solution. Don't forget to check those. Next part is write each equation in vertex form by completing the square. Completing the square is half its squared added to both sides. So remember, in completing the square, you pull that over to the other side, leaving a space, And now we're going to use the coefficient here. We're going to cut it in half to get -3. We're going to square it to get 9. We get plus 9 plus 9, add it to both sides. When we factor this, we're going to get x minus 3 squared, because remember, you better get this right here in your factored part. And that is equal to 6. And now remember vertex form, we have to have f of x equals. We're going to pull that number back to that side. We have x minus 3 being squared, and that is minus 6. And you can see the vertex. It's the opposite of this, the same as this, and there we go. On the next one, very similar, except for a little bit more difficult because you have this leading coefficient of 2 that we're going to have to factor out. So I'm going to pull over that -2 on the other side, so it'll become a positive 2. Now I'm going to factor out the 2 from this side. And now I'm going to take this number, half it, square it, add it to both sides. When I half it, I get -2. That's how this is going to be factored. When I square it, I'm adding 4 to this side, but really I'm trying to figure out what I'm adding here. So when I redistribute this back, I get here, here's here, and this one here is a plus 8. So what I'm adding to this side is a plus 8, which now this here is factorable. Remember, it's going to be the x minus 2 being squared, and that's equal to 10. Pulling that over to the other side and write it f of x equals, we get x minus 2 squared minus a 10, and the vertex, the opposite of that, the same as that. All right, quadratic formula, I have it listed for you up here. I will give that to you on the test, but you need to know on the final. You need to make sure that you are putting this in standard form first before you find your A, your B, and your C. Our A is equal to 4, the B is equal to -5, and C is equal to -6. So x equals opposite b, or negative b, and negative is positive, plus or minus b squared, -5 squared is 25, minus 4 times a is 4, times c is -6, all over 2 times a, so that's going to be an 8. When I figure out the determinant right there, or discriminant, sorry, I have a negative times a positive times a negative. It's going to be plus. So I have, okay, so what I have is 5 plus or minus. I have 25 plus 96 under the radical, which is going to be 121. So 5 plus or minus the square root of 121 all over 8. This is a perfect square. It breaks down to 11 and 11. So 5 plus or minus 11 all over 8. All numbers break it up. 5 plus 11 divided by 8. 5 minus 11 all divided by 8. And I get my two answers. This one is 2. -6/8, which is reduced to -3/4. All right, the next one, my A value is -8. My B value is -10. My C value is -1. I don't have to rearrange anything. X equals -b, +10, plus or minus the square root of 100 minus 4 times -8 times -1. This right here is going to be a -32, which is going to make that, sorry, I forgot the all over 2a. So that's -16. Okay, so what we have here is we have 10 plus or minus the square root of 68 all over -16. When I break down the 68, I will tell you what you're going to get is 2 square root of 17. And now you can see this is divisible by 2, so I'll factor that out. So 5 plus or minus the square root of 17 all over -16. That'll be a 1. That's going to be an 8. I'm not going to rewrite this because I'm running out of space, but that's going to be my answer right there. All right, next one, A is 12, B is -1, C is +1. It's already in the right order. X equals -b. That's 1 plus or minus the square root of 1 minus 4 times 12 times 1, all over 24. And here I have a negative 48, so it's going to be a negative 47 underneath the radical. So the answer is going to be imaginary. And I need to take the imaginary part out, so it's 1 plus or minus I times the square root of 47 all over 24. 47 is a prime number, so you can't go any further, so you're done. All right, solve using SADMIP is reverse order of operations. You're trying to undo the x, but you have x squared, so you have 2 answers. So you'll have a plus or minus. So you first divide by 3. That's going to give you here 36. So we have x squared equals 36. When I now undo the squared by taking the square root, I have to put the plus or minus to get my 2 answers. So I get x equals plus or minus 6 because that's a perfect square. Next one, subtract 11. I have 4x squared is equal to 10. Divide by 4, divide by 4. X squared is equal to 5/2. Now when I take the square root of both sides, I'm going to take square root of both sides, put the plus or minus. This here is the same. Oops, sorry, I changed that to a 4. I'm doing some steps ahead of myself. This here is the same as saying square root of 5 over the square root of 4. And I'm doing that because this right here is a perfect square of 2, and you can't have a radical in the denominator. So what I get is x is equal plus or minus the square root of 5 all over 2. Next one, I'm going to add 5 to both sides. That's going to give me 16. I now have 2/3 x squared equal to 16. Multiplying by 3/2 is going to remove the fraction over there. And now, if I put that over 1, I can reduce, or I could just immediately multiply and reduce later. And you get x squared equals 24. Taking the square root of both sides, again, do not forget the plus or minus. You get x equals plus or minus square root of 24. When you break this down, you're going to get 2 square root of 6. So x equals plus or minus 2 square root of 6. And actually, I'm noticing on the answer key, I changed it. So if you have the changed copy, what you have is this plus 5 equals negative 11. Everything would be exactly the same, except for you get a negative underneath the radical. And you're going to have one like this on your final exam, so I'm going to continue to do this regardless of what yours is. Oops, what did I do here? I flipped that around. Let's flip that. It should be times negative 3/2. Again, same math going on here, except for you get a negative 24 right here. So when you take the square root of both sides, you have an imaginary unit, so you'll get the same answer, x equals plus or minus 2i times the square root of 6. So the same answer, you just had the imaginary part in front of it. All right, you spend a lot of time with this. The first one's in standard form. You have to do x equals negative b, so negative 2 over 2 times negative 1, which is going to be 1. So you have x equals 1, which is your line of symmetry. It's also your x value on your vertex. So I'm going to put that in. To get my y value, I need to plug in 1 into this. And remember, that negative comes afterwards. So you square 1 to get 1, then you have a negative 1. So you have negative 1 plus a 2 plus a 4. So you have negative 5. Sorry, not negative 5, it's a positive 5. So you have 1, 5 right here. This is going to open down because it's negative. X-intercepts, I'm going to let the function equal 0, so f of x equals 0. And then you're going to use the quadratic formula. Anytime you're using x equal negative b over 2a, you use the quadratic formula. And I'm just going to write the answer here. It's 1 plus or minus the square root of 10 comma 0. But again, you have to use the quadratic formula. We just did that on the other page. Y-intercept, you're going to let x equal 0. When you let the x's equal 0, what you're left with is a 4. So you get 0 comma 4. And 0, 4 is the 1 point that we can put. And then we can draw this. We can't put our x-intercepts on because that is irrational. Next one, x equals negative b over 2 times a. You get x equals 2 as your line of symmetry. Also, that's your vertex point. I'll put that in. When I let x equal 2, I have 4, 8, 0. So 2 zeros right here. When the vertex is on there, that's also going to be my x-intercepts, and I only have one. And my y-intercept, when I let the x's equal 0, is 0 minus 0 plus 4. So I get 0 comma 4. And 0, 4 is right here. Reflecting on the other side is right here. And that's my answer. On the next one, we have vertex form. Vertex form, you can quickly identify the vertex, the opposite of this, the same as this. So negative 2, 1. The line of symmetry is x equals negative 2. X-intercepts, we're going to let the function equal 0 right there. And when you do, you get, first have to take and subtract 1. Now you get negative 1 equals x plus 2 being squared. When you take the square root of both sides, don't forget the plus or minus, gives you your two solutions. You have this right here. This is an imaginary unit, so you have plus or minus I times the square root of 1. Square root of 1 is just 1. So we have one more step to subtract 2. So you have negative 2 plus or minus, I'm off the screen, negative 2 plus or minus I. And negative 2 plus or minus I, comma 0. We can't put that on the graph either. Oops, sorry, I forgot to put these on the graph. Negative 2, 1. Y-intercept, when we let all the x's equal 0, we have 0 plus 2 squared plus 1. This is 2 squared, 4. 4 plus 1 is 5. So what we have is 0 comma 5. 0, 5 is right here. Reflected on the other side is right here. And that is our function. All right, let's see. Guess I can't move that down. Interesting. Okay. Vertex is opposite of this, negative 2 comma 3. Negative 2, 3 is right here. Line of symmetry is x equals negative 2. X-intercept, when I let the function equal 0, I'm going to first subtract 3. Now I have to remove this negative because that's like a negative 1 being multiplied, so I'm going to divide that to the other side. That'll give me a positive 3. Oops, I didn't mean to write that. Equals, that's what I meant to write. That being squared, taking the square root of both sides, don't forget the plus or minus. So what I now have is x plus 2 equals plus or minus square root of 3. And when I subtract 2, subtracting 2 will go out in the front. So it'll be negative 2 plus or minus the square root of 3, comma 0. Y-intercept, let all the x's equal 0. And this here is 2. When I square 2, I get 4. The negative comes afterwards. When I add that, I get negative 1. So I have 0, negative 1. Reflecting it on the other side is right here. Those are the only points I can put on. And that is my graph. The next two are also vertex form. I'm just going to write the answers in on here, and you can check your answers because I just went over the previous ones. They're the same. And just notice on this first one here that the x-intercept and the y-intercept are the same, so you only have that 1 point there to graph it. Okay, looking at it in factored form, I immediately can see the zeros. This one here is x equals negative 3, so negative 3, 0. This one here is 1, so 1, 0. And when I plot negative 3, 0, and 1, 0, remember the line of symmetry cuts it in half, and that right there is x equals negative 1. That is also my x value to my vertex. When I plug in negative 1, I'll get my y value. So this here is 2, this is a negative 2, and that's equal to negative 4. So here I have this point right here. Y-intercept, when I let the x equal 0, I have 0 plus 3 times the quantity 0 minus 1. I have 3 times negative 1, or simply negative 3. So 0, negative 3 is right here, reflecting here, and there's my parabola. All right, to write the standard form of a circle, remember the equation is x minus 8 squared equals y minus k squared is equal to r squared. So here's the center, so it's going to be x minus 2 squared, oops, sorry, this is a plus sign, plus y minus 1 squared. And our radius is 5, so you have to square it to the equation here. Where you use the radius being 5 is right here when you go out 5 units in all directions. 5 to draw your circle right here. Okay, write the equation of a circle given the center is this, so you immediately know it's x plus 2 is being squared, and you have y plus 7 is being squared, and you know this is equal to the radius squared. And to get the radius, you have to use this other point. This point represents x and a y, so you'll substitute that in for the x and in for the y, and you're going to get this. This is going to be what r squared is equal to. So 11 squared is 121. 5 squared is 25. So this is equal to 146, which that was your r squared. So that's what goes in your equation. So it's x plus 2 squared plus y plus 7 squared is equal to 146. Okay, next one, I'm giving you just the endpoints. So if the endpoints are -5 and 3, you have to average the x's. So -5 plus 3 divided by 2 is -1. Average of the y's is going to be 8 plus 4 divided by 2, which is 6. So the center is x plus 1 squared plus y minus 6 squared. Doing the same thing to get the r squared. Pick either one of these points. That one's smaller. 3 plus 1 is 4, squared is 16. 4 minus 6, -2 squared is 4. That's going to give me my r squared of 20, and that's my equation right there. Next one's the same way. If I average these, I get -2 divided by 2. That'll be -1. If I average these, I get -10 divided by 2, -5. That's my center. So x plus 1 is squared plus y plus 5 is squared is equal to the r squared. And again, picking either one of these points, 4 plus 1 is 5, squared is 25. -3 plus 5 is 2 squared. So what I get for my r squared is 29, which goes in the equation. All right, last one on this page, completing the square of a circle, group the x's together, leave a space, group the y's together, leave a space, push the number to the other side, half it, square it, add it to both sides. There's no coefficient, you have to multiply back, so this one's pretty easy. Half it, square it, add it to both sides. You can see on this side it's equal to 9. When I factor this, I get x minus 2 squared. I better get what's right here. When I factor this, I get y plus 1 squared. I better get what's right there. And that's equal to 9. And that will be my answer in standard form, because it's equal to r squared. And my center is the opposite of this, so 2, -1. This has been squared, so my radius is the square root of that, which is 3. All right, graphing ellipses. So this is already in standard form because it's equal to 1. Find the x. Opposite of this is 4. Opposite of this, there's nothing in there, so it's 0. Make sure you pay attention to the order. It doesn't have to be, x doesn't have to be first. So there's your center. Remember, you have to find a squared, b squared, and c squared. A squared is always the largest number, so 16. B squared is 4, c squared is a squared minus b squared, so 12. We want our a value plus or minus 4, b value plus or minus 2, c value plus or minus square root of 12 to 3.5 about. We're guessing. Okay, so now what we're going to do is locate that center, 4, 0. This has a stretch on the y, so it's going to look like this. And we're going to go up and down the a value, up and down 4. 1, 2, 3, 4. 1, 2, 3, 4. Those are our vertices. So what I have is 4, 4, and I have 4, negative 5. Oh, I did that wrong. I counted wrong. So it should be 4, negative 4. Okay, co-vertices with the b value, we're going to go plus or minus 2. So here and here. So I have 2, 0, and I have 6, 0. And the foci is going to go close to the vertices, plus or minus 3.5. So that's the F there. Right about here is the F. So I'm going to get... it is 4, comma, and if I take this and plus or minus 3.5, what I'm going to get is a 3.5 and a negative 3.5. And there it is. This one is not in standard form because it is not equal to 1, so we have to divide everything by 225. And when we do that, what we get, this is 9, so I have y plus 2. Oh, I'll put it right here. Y plus 2 squared all over 9. And this one here is x minus 1 squared 25 equals 1. Okay, center is, here's my x value this time. Be very careful. 1 comma negative 2. So 1 negative 2 is right here. My a squared, b squared, c squared. A squared is the bigger number, 25. B squared is the smaller number, 9. C squared is subtracting these, 16. That leaves me with an A of plus or minus 5, B plus or minus 3, C plus or minus 4. So in finding the vertices, this has a stretch on the x, so it's going to go this way this time. So I'm going to go left and right 5 units, 1, 2, 3, 4, 5. That one is 6, negative 2. 1, 2, 3, 4, 5, negative 4, negative 2. And with the co-vertices, I'm going to go plus or minus 3, 1, 2, 3. So I have 1, 1. And 1, 2, 3. So 1, negative 5. This is my ellipse. My foci are going to be plus or minus 4. So 1, 2, 3, 4. So that is 5, 5, negative 2. And this one is 1, 2, 3, 4. So negative 3, comma, negative 2. All right, to write the equation of ellipse in standard form by completing the square, group the x's together, leave a space. Group the y's together, leave a space. Throw the number to the other side. These both have leading coefficients that you have to factor out. So we'll have to multiply those back in before we add to the other side. All right, half it squared added to both sides. We're going to take negative 6, cut it in half, we get negative 3. When we square that, we add 9 to this side, but really what we're adding up here is a 36. So we'll add a 36 to this side. Same with here, 4, half it, 2, square it, 4. You're adding a 4 here, but truly what you're adding is 100, so you get a 100 right here. So what I have when I factor this is an x minus 3 being squared. I have a 5 on the outside, a y plus 2 being squared, and on this side it's equal to 100. And of course this has to equal 1, so we have to divide this 100 to the other side. And what we now get is we get x minus 3 squared over 25 plus y plus 2 squared over 20 is equal to 1, and that's our equation in standard form. All right, taking a look at the first one, standard form of ellipse, remember, is x minus h squared plus y minus k squared equals 1, and a squared is the bigger number. And you can tell where the stretch is because, well, here it says major endpoints. Major endpoints is the larger one. That's going to get the a squared. And you can see the stretches on the x. So my a squared is going to go under here, and this will get my b squared. So you can see my stretch from negative 1 to 7. You have a distance of 8 units. And remember, I have to cut that in half. to get my a value, so a is equal to 4. And to find the midpoint in between here, I have to take -1 plus 7 and divide it by 2, and that's going to give me 3. So 3 is my midpoint. So what I currently have, that's going to be for my center, for my x. I'm just going to write that as an ordered pair. I'm going to do the same thing. Oh, well, I could have just also looked at it from here. There's my x, here's my y, -2, okay? You could also do the same thing, average those. All right, finding now my b value, I'm going to look at the stretch from 2 to 6. And from 2 to 6, I have 4 units. And when I divide that by 2, I get 2. That'll be my b value. So putting this all together, I have x minus 3 being squared all over 16 plus y minus plus 2 squared all over b squared was 2, so 2 squared is 4, and that's always equal to 1, which is my answer. All right, looking at the next one, actually exactly the same, and I'm going to use the shortcut this time. You can see my x's right here are 2's, they're the same. My y's are going to be the 5, that is my center. You also know that the stretch, well, major axis, so the stretch here is on the y values, and the difference between 2 and 8, the distance between these two is 6. Cut this in half, I get 3, so my a squared is 3, which is going to go on the y value. When I look at my change in x values here, I have a change of 2 divided by 2 is 1, and that is going to be, I put a squared here and I meant a, okay. So this here is going to be my b value, and that, because it's on the x's, will go on the x's. So what I have in putting that all together, I have x minus 2 being squared plus y minus 5 being squared. My x value, I said, was getting a b was 1, so I'm going to take 1 and square it. And then my a value was 3. 3 and squared is 9, and this is going to be my answer right there. Standard form with lifts with the foci and vertices. All right, so let's see. Here I have an x value or a center of 2, and you can see that with all of them. I don't know my y value, so I have to find the average of my y values here or here, and I should get the same number. When I go -3 plus 5 divided by 2, I get 1. When I go -4 plus 6 divided by 2, I get 1. So you can see that is my y value with either one. Finding the vertices gives me my a value. You can see the stretches on the y. So I'm going to find the distance between -4 and 6, which is 10, but I have to cut that in half. So 5 is my a value. And this one right here, my foci gives me my c value. The distance between -3 and 5 is 8. When I take 8 and cut it in half, I get 4, so my c value is going to be 4. Remember, a squared minus b squared equals c squared, so my a value was 5, so I have 25 minus b squared. My c value is 4, so 16. If I put a 9, if I put, a 9 in there, my b squared is equal to 9, so my b is equal to 3. So now I'm kind of all over the place, putting it all together. X minus 2 squared plus y minus 1 squared. This is going to equal 1. And I said my y gets my a value, and I said a was 5. So 5 squared is 25. My b value, where's my b value? There's c. B value is 3, and b squared goes onto here, and that gets a 9. There's my answer for that. All right, when I have vertices and co-vertices, my vertices is my a value. You can see my a value, the stretches on the y. So I have x minus h squared. That'll be the b plus y minus k squared. That gets the a is equal to 1. And you can see my center is 5, comma, -1. So I have x plus 5 and a y plus 1. and I need to find my b squared. So going back to my vertices here, I gotta erase some of this stuff. I can't even see my numbers anymore. Circled these too many times. Okay, let's also change colors. All right, so you can see my vertices here. I have a difference of 10. Cutting 10 in half is 5. So 5 is my a value, but I need a squared, and so that's going to be a 25 there. And looking at my change in my x values, I have a difference right there between these two of 6. When I cut that in half, I get 3, and when I square 3, I get 9, and that's what goes under my x squared right there. Okay, exponential function. Remember, the base remains the base. The other two switch places. So you get 6 to the negative second equals 1 over 36, which is a true statement. Base remains the base. The other two switch paces. You get that true statement. Down here, you have to write it in logarithmic form. You'll introduce logs. The base of this is a 4. That becomes the base of this. The other two switch places, so the 64 is first, and it's equal to 36. The base remains the base. Oh, oops, that's a 2. The other two, oh, dang it. The other, well, base remains the base. The other two switch places, so you're going to have this is equal to that. When you're solving for this, you have to first write it in exponential form, so you'd have to put an x there. Base remains the base. The other two switch places, and you can see to make that true, x has to equal 4. Next one, you would get 2 to the x equals 1, and the only way with a power is that x is equal to 0. Any number to the 0 power is equal to 1. Next one, you have 7 to the x equals 7, and to make that true, because that's a 1, you have x equals 1. And the next one is 2 to the x equals 1 over 32. And remember, in order to create a fraction, you need a negative exponent, so you're going to need a negative 5 for that. All right, to condense, we have to get this down to one term of log. So we have log base 3. This will act as an exponent, which is actually going to make that a square root of 2. This acts as an exponent, which is x squared. This acts as an exponent, which makes that the square root of y. This acts as an exponent. We all have exponents on this. Okay, now remember, addition and subtraction go together. I can't see what sign I have here. Minus, okay. So anything with a plus sign in front of it goes on the top. Of course, the 2 square root of 2 is starting on the top. We have subtraction, so the x squared goes on the bottom. The square root of y goes on the top, which will merge with that square root of 2. And then we have z to the 4th on the bottom because of the subtraction. Okay, right here we have square root of x. This is going to be square root of 64. Square root of 64 is 8. And this is z to the 5th. So what we have is this. We have log, the base is 2. We have an x on the top. We also have the 8 on the top. I'm going to put that in the front. On the bottom, we have the 16, and we have the z to the 5th. And of course, I can reduce that fraction right there. So what I have is log the base 2. I have x over 2 z to the 5th right there. Okay, to solve for an exponent, when a variable is as an exponent, you either need to change the bases to get them to be the same, which I cannot do for this one, or you have to take the log of both sides, which is what I'm going to have to do. That, taking the log of both sides, remember, allows me to pull down the exponent, so I can make this 3x minus 1 times the log of 14 is equal to the log of 7. When I'm solving for x, I need to divide that log of 14 to both sides. And you cannot ever reduce that fraction. I'm kind of running out of space, but I'm going to add the 1, which I'm not going to combine with that fraction. And now I have 3x is equal to that mess, and I have to divide by 3. The 3 is going to go on the bottom right here, and it goes on the bottom right there. So this right here, as messy as it is my answer. The next one, I can get the bases to be the same because I can make this 4 squared, and this is already a 4. And now I can just simply put the exponents to be the same. So distributing that is a 6x minus 2, and then I have an x plus 2. So subtracting the x, I get a 5x equals 4, so I get x equals 4/5, and that is good. Next one, I can't make this 2 or 3 to a power, so I can't make the bases be the same, so I have to take the log of both sides. And when I do, that'll allow me to punch down that 2x, it is an n, but 2x minus 1 times the log of 12, which will then be equal to the log of 64. I'll divide both sides by the log of 12. That's gone. Now when I add 1 to both sides, what I get is log of 64 over log of 12. And I have a plus 1 that follows this. And when I divide by 2, that's going to join this in the denominator. And divide this by 2, this is going to be my answer for the x right there. All right, the next 4 all have logs in them, and you will notice that I have 2 logs on one side, which means I need to condense this. And I will condense this down to 1 term of log. It doesn't go away. It just turns to 1 log, and it condenses like this. Now I need to remove the log by writing it in exponential form. The base remains the base. The other 2 switch places. So what I have is this right here. If I multiply by the x minus 1 to both sides, I'll have to distribute that. So I get a 4x minus 4 is equal to x plus 2. And what I'm going to get is I'm going to get 3x is equal to 6. So x is equal to 2. Again, double check to make sure it's not negative, and it's not, so that answer works. The next one, there's only 1 term of log. It's already isolated, so I'm going to write this in exponential form. The base remains the base. The other 2 switch places. And 4 to the third is 64, which is equal to 2x plus 4. When I subtract the 4, I get this, and divide by 2, I get x equals 30. All right, the next one is probably the easiest because you have 1 log with base 3 equal to 1 log. So because these are the same, these 2 have to be the same. So 2x has to equal x plus 6, which means x is equal to 6. And that gives me a positive answer, and so does that, so I am done. And the last one, it has only 1 term of log, very similar to 94, except you don't see the base, it's a 10. It's 10 to the negative 1 is equal to 4x. 10 to the negative 1 is 1 over 10 to the first power. And if I multiply both sides by 10 to remove that fraction, I now have 1 equals 40x. And dividing by 40 is going to be x is equal to 1 over 40. And there's my answer.